FlowHow, sales of Moldex3D and consultancy, specialists in injection molding simulations. Hello, Mads Jespersen from FlowHow. In this small video I want to show you what you can use the particle tracer for in the Moldex3D. In this case I will show you how a small example of how you can increase strength of a weld line with creating underflow in the weld line. The underflow will give a weld line that has a strength that's nearly the same as an ordinary material. But let's look at the model. We have this model. It's I've done 2 models, but this model is a plate, and then I fill the plate with 2 gate points, so you get I get a weld line in the middle. If I go to the filling results, I can just do it like this, and then I can try to push it here, and then we can, now you see the weld line will be here, and the part is filled equally around the center. What's important and what I will have focus on here is the particle tracer, and I can go down to the particle tracer. It's a result that you can choose to have in a filling, and then it's possible for me then to follow the particles coming out from the gate point, and you can see here we have the weld line, and it's on 100% filled. I've done another model where I tried, in this case I have just moved one gate point 5 millimeters out from here to here, and when I do this I get a different filling pattern. See, then we have the weld line created at the middle, and when I go further it just fills up, and then it needs to fill the end at least because of the flow length out to that that edge is longer than from this point out to that edge, and then it fills up. One thing is what's happened on top, that we can see, okay, now we get a weld line here, but what we can see in this filling pattern is only the skin. If we go over to the particle tracer, we can look inside and see what's really happening inside. Maybe we should go to a bit smaller, like this. And again, fills up, particles coming out from the gate points. In this area we can see the weld line is created now, and it fills, and when it hits this wall, have a view in this one. The whole melt front is moving because this gate is trying also to fill this area down. So you have some flow from this gate through the weld line and down here, and that's called underflow of the weld line, and then you get a really then you get strengthened up the weld line dramatically. So one thing is placing the gates symmetrical, but if you have a weld line in a plastic part, sometimes if the strength is the design giving specification, then you have to think, should the gate points be placed symmetrical in the part if it's a symmetrical part. But what happens when we place the gate points not symmetrical? We can look at it costs of course something, because normally it's recommended to have a balanced filling of a part. And what it costs is, if we go down to XY compare, that's the comparison between the symmetrical and non-symmetrical results. We can look at the pressure through the filling, and we can look if we had the red one going up here, down here, it ends up around 180 bar of filling pressure. But due to the unbalanced filling, the green one, we have a pressure peak here, and it ends up with around 220 bar, around 20% higher packing pressure. It's not a problem in this part, but if we are at a limit of a clamping force for a machine, it's really needed to be very keen on that you have not too high filling pressure. What you really could do was you can make a profile injection speed and go down in injection speed at that time where you get this area filled out, then go down to half injection speed, and you'll not have so much pressure peak as you have up here. That is what I want to tell you about that small feature, particle tracer in the Moldex3D. Thanks for watching, and have a great day.